All right, and the last problem of challenge day 2. This is the other super challenging problem. But if you want to see if you did it right, then you're in the right place. All right, so for what value or values of x would make triangle ABC similar to triangle EDC? And this is not a good sign when it says round your answer or answers to the nearest tenth. That means we're not going to get some nice numbers. All right, so ABC, notice if I just put 1, 2, and 3 arc marks on there, similar to triangle EDC, and I go 1, 2, 3 arc marks on that. Obviously, I can tell my vertical angles are the same, but notice the triangles are kind of twisted on each other. They've been reflected on each other. So that means our corresponding sides is the 2x minus 5 side AC, is going to correspond to side EC, which isn't the 2x minus 6, it is the x plus 3. And that means the 3x minus 6 side is needing to correspond to the 2x minus 6 side. Now, realize I'm not saying that these triangles are similar and I need you to solve for x, but what particular values of x would make these triangles similar? And so notice we've got, in one scenario, a side, and an angle in between those two sides. And we get the same scenario over here in the other triangle. So we're trying to establish side angle side similarity. So in the end of this problem, what we're going to be concluding is if x were this particular value or values, then side angle side similarity would exist. And if it does exist, then our triangles are similar. So I'm just trying to figure out the particular value or values that really would make these triangles similar to each other. Okay, so I'm not saying that they are similar and then here's the value of x. I'm saying if this was the value of x, then we would have similar triangles. Okay, so when I set up my proportion, and again, I'm not saying that this is true. Basically what I'm stating is if this proportion is true, then side angle side similarity exists. All right, so let's just backtrack to this part right here. If this proportion works out, if this proportion is equal, if these two ratios are equal, then the 2x minus 5 side would match up to the x plus 3 side. And then going back to the first triangle, the 3x minus 6 side would need to match up to the 2x minus 6 side. And so now we're going to need to cross multiply. And notice this is not going to produce anything that's going to take a little amount of time. We are going to have to FOIL or double distribute on both sides. So let me get all this written out here. Okay, so now distribute the 2x to the 2x and the minus 6. We'll get 4x squared minus 12x, and then distribute the negative 5 to the 2x and the negative 6, and we'll get negative 10x plus 30 equals, and now we can go FOIL and double distribute on the other side, but I just need to scoot this over to get a little bit more space here. Let's distribute the 3x to the x and the 3, so we'll have 3x squared plus 9x, and then let's distribute the negative 6 to the x and a 3. So we got minus 6x minus 18. So let's clean all of this up here. So we have 4x squared. We've got two x terms over here. So negative 22x's plus 30 equals 3x squared. And we've got two x terms over here, which give us plus 3x, and then minus 18. Now, this is looking like a factoring problem, but I need to move everything over to the same side. So I'm going to subtract these 3x squares over to the 4x squares. I'm going to subtract these 3x's over to these negative 22x's. And I'm going to add this 18 over to the 30. So gone, gone, gone. 0 on the right side. I've got just a single x squared, 1x squared if you want, minus 25x plus 48 equals 0. All right, so let me get some space up here, move this up. So now this does appear to be a factoring problem. So I need to find two numbers that multiply to be positive 48 right? If I take the 48 times the 1, and I need those two numbers to add to be negative 25. And, so if the two numbers have to add to be negative, but they multiply to be positive, that means my two numbers are going to have to be negative. So if I had negative 1 times negative 48, well, that adds up to be negative 49, so too high. Negative 2 and negative 24. Those add to be negative 26, really, really close. But watch what happens when I find the next factors, which would be negative 3 and negative 16 adds up to be negative 19. I've skipped over negative 25, right? To get from negative 26 to negative 19, there's nothing going to be in between negative 2 and negative 3, which means this will not factor. This means we're going to have to use the quadratic formula. If you need to go get some tissues, you can go get some tissues now. But I've already got this set up for the quadratic formula in perfect ABC order here. And so, let's get some more space, why don't we? Let's clear some of this out. Basically, let's just start fresh from the quadratic formula. We don't need any of this because factoring didn't work. And let's shove all of this. Of course, it's not all attached. Why would it need to be attached? There we go. Push all this right up. We'll put it right here. So then x equals, and first I'll write out the quadratic formula, negative b plus or minus square root b squared minus 4 times a times c all over 2a. So now x equals negative b, but b is already negative 25, so negative b would be positive 25, plus or minus square root b squared, negative 25 squared is going to be 625, always positive b squared, minus 4 times 1 times c, 48. And I'll come back to that later. All over 2 times 1, 2. So then we got x equals 25 plus or minus the square root of, let's do a little bit of double up math here. 4 times 48 is, let's see, 192. So really I'm taking 625 minus 192, and I get, this is really the square root of 433. So, remember it said to round my answers to the nearest 10th, which means I'm not going to leave this nice, lovely fractional square root answer. They're basically saying you can go ahead and plug all this into your calculator and just get some decimals. So what's that going to look like? Well, we got to split up the plus and minus now. So we're going to do 25 minus the square root of 433 divided by 2, and we're going to do 25 plus the square root of 433 divided by 2. And so let's figure out what those come out to be approximately. So if I do 25 minus the square root of 433 on my calculator and press enter, and then say divided by 2, I get that that comes out to be approximately 2 point, and it's 0.95 blah, 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 blah. But to the nearest 10th, that would just be 2.1. And now if I go back and do 25 plus the root 433, hit enter, divided by 2, I get that x could also be 22.9 to the nearest 10th. So this is interesting now. We get two positive values here. Typically, we've seen in the past a positive and a negative answer, but we get two positive answers. But the directions just say for what value or values, so hey, maybe these are both legitimate. But we really need to plug these in to see if we end up with positive lengths across our whole problem. So I'm going to start with the smaller value, because the smaller one's probably going to be the problematic one. But let's see. If I put 2.1 in for this x, hey, I get a positive length, 5.1. Cool. If I put 2.1 in right here, 3 times 2.1 is 6.3 minus 6. I mean, this is small, but it ends up being positive 0.3, so that works. If I put in 2.1 up here, 2 times 2.1 is 4.2. 4.2 minus 6. Ooh, negative 1.8. And we're also going to see the same kind of thing happen here. 2 times 2.1, 4.2. 4.2 minus 5, negative 0.8. So definite no-nos here. when I plug in that 2.1, I am not getting positive lengths overall. Now, I can plug in the 22.9s, and I will guarantee you that no matter if I subtract 5 or 6 or 6 from 2 times 22.9, I am not going to be going below 0. So in the end, the only answer that works is positive 22.9. So in the end, here's what we're really saying. If x is approximately 22.9, then, oh, let me go back one more. There we go. Then triangle ABC will be similar to triangle EDC by side angle side similarity. Because if I go plug this back in, I'm going to get side links for this piece and this piece, and for this piece and this piece, and they will be in equal ratios, because that's how I got the 22.9 to begin with. Now, don't fret, I will not have anything that will involve you using the quadratic formula on the test. But this is a super challenging problem.